All right, welcome back to part two of the intelligence unit. Okay, so we finished up with a couple different theories of intelligence, the difference between G and S, Howard Gardner's multiple intelligence theory, and now we're going to talk about modern intelligence tests and how we got there. So the original intelligence test was developed by Simon and Binet, and Stanford was the institution they developed it at. So for a while, it was called the Stanford-Binet test. But anyway, the original test, as I mentioned in the first video, was meant to identify mentally handicapped students. It was meant to identify students who would benefit from a special education setting, who might not benefit from a normal classroom setting. And they did this by developing a test that gave a score, and they wanted to determine a child's relative mental age, meaning if they're 6 years old physically, how old are they mentally? Are they 6 years old mentally? Because they should be, that'd be the average. But if they are mentally the age of a 3-year-old, yet they are 6 years of age, then that is a child that might benefit from special education services. So they used the terms bright and dull. Obviously, those are not politically correct anymore, but that is what they originally used. All right, so the the test produced what's called an intelligence quotient, or an IQ. That's what IQ stands for, intelligence quotient. That little note there, Lewis Terman, we're going to talk about Lewis Terman in a little bit, but he was one of the big names in early intelligence research. Excuse me. So the IQ, the intelligence quotient, is a ratio of someone's mental age compared to their chronological age and then multiplied by 100, because we like nice, neat, round numbers like 100. So an IQ is your mental age divided by your chronological age times 100. So what does this tell us? If your mental age is above your chronicle age, so if you are 10 years old, but you have the mental age of a 15-year-old, then you will have an IQ above 100. If you have the mental age of a 5-year-old and you are 10 years old, then you will have an IQ below 100. So 100 is meant to be the average. It's meant to be when someone's mental age and chronological age are the same. If your mental age is 10 and your chronological age is 10, then you will have an IQ of 100. And the test is designed that way on purpose. So the original Stanford-Binet IQ test, it measures necessary skills for school success. Now remember, that shouldn't come as a surprise because that is what the test was originally meant to do. How well in school will a child do? Will they do just fine in a normal classroom setting, or do they need some special services? So it tested things like language, memory, the ability to follow instructions, and computational skills, leaning pretty heavily on that logical, mathematical intelligence, like Gardner said. Binet's test is age graded, meaning that if you are 5 years old, you will get a test designed for 5-year-olds. If you're 10 years old, you will get a different test, a test that is designed for 10-year-olds. So the researchers, the people who make these tests, they try to make them age appropriate, meaning there will be probably one test for every different year of life out there. So I mentioned this on the last slide, but children whose mental age is equal to their chronological age, they are considered to be average. They will have an IQ of 100. If your IQ is less than 100, if your mental age is significantly less than your chronological age, then this might meet the definition for intellectually handicapped. And then they would be referred to special education. All right. Like I said before, that was the original IQ test, the Stanford Binet or Simon and Binet test. And now fast forward to today, where we have modern IQ tests. They still haven't really left behind their original history of being a school admissions test, for better or for worse. So today we still use the same metrics. So at any age, we have age appropriate IQ tests. And if you have an IQ of 100, that is exactly average. That means your mental age and your chronological age are the same. You have a mental age that is exactly what we would expect for someone of your age. They are standardized and we have established norms. What that means is that these IQ tests, modern IQ tests, are given to hundreds and hundreds of people of different ages, and we have established where the average for each age lies. Now, what this allows us to do, and sometimes is done very wrongly, very erroneously, is to compare individuals. We can look at IQ tests from different people and we can make comparisons of basically how intelligent someone is based on an IQ score. Is that something we should be doing? I would argue no, but we'll get to that in a little bit here. So before we move on, let's talk a little bit about the standard curve, the normal distribution. If you have taken a statistics course, whether that's inside psychology or not, you are probably familiar with what's on this slide right here. So on this slide, we have a standard distribution, a normal distribution. And for IQ scores, just like virtually every other measurable variable on the planet, we have this bell-curved normal distribution. The normal distribution for IQ scores, as we've already mentioned, is centered on 100. That is by design, that is intentional. So the average is 100. So if you took every person on the planet and you gave them an IQ test, the average would be 100, assuming the test is properly designed. That's your mean, your average is 100. Now a standard deviation on the IQ test or IQ scores normal distribution is 15. So a standard deviation on a normal distribution is something special. It tells us something special. Within one standard deviation of the mean, which again is 15. So if you go 15 IQ points above 100 and 15 IQ points below 100, that range that I just described is going to capture roughly 68% of the population. So over half, almost 3/4 of the population falls within one standard deviation of the mean. So almost 3/4 of the population has an IQ somewhere between 85 and 115. Now, if you go out 2 standard deviations from the mean, which would be 30 IQ points, so you go 30 IQ points below 100 all the way to 70, and then you go 30 IQ points above 100 all the way to 130, you have a much wider range and you capture a much wider or a much greater population of IQ scores. In this case, you capture about 95% of the population. So 95% of people on the planet, if they were to take an IQ test, they would have a score somewhere between 70 and 130. If you fell outside of that range, you would be in a very small percentage of people on this planet. About 5% of the people on this planet would have an IQ score outside of that range of 2 standard deviations, 70 all the way up to 130. So that is our clinical definition of abnormal. if you fall within that 5%, that is the clinical definition of abnormal. Now, we have 5%, but we've got two sides of the curve that 5% has to fall on. So we have actually 2.5% on the lower end and then 2.5% on the upper end. So 2.5% of people have an IQ below 70, and 2.5% of people have an IQ above 130. I hope I explained that somewhat well, clear as mud kind of the idea. But if you're familiar with the normal distribution, just know that IQ scores are a variable that also make a normal distribution, and the IQ tests that we use today are centered on 100, and a standard deviation on this normal distribution is 15. So what happens if we want to compare people based on their IQ score? So if we want to do that, our intelligence relative to others, meaning we're going to compare based on others of the same age, that is useful when we are younger. But as we get older, the usefulness of that comparison diminishes pretty quickly. And we'll talk about that in just a second here. Modern IQ tests are very useful for guessing someone's school performance. IQ tests do a decent job of allowing us to predict how well someone is going to do in school. And remember, that is what they were originally designed for. How well would a student do in a typical classroom environment? So it's really not that surprising that today, 100 years later, they still do the same thing that they were originally designed to do. Now, it's really important to note here that an IQ score can help measure performance, but it can't explain that performance. And that is where the whole field of intelligence research that's what they're trying to do. They're trying to explain why certain people get certain scores on an IQ test. And we don't really have a totally satisfactory answer for that yet. All right, so let's talk about this a little bit more. Do intelligence tests really work? Yes, we can get an IQ score. Yes, we can compare it to another IQ score if we really want to. Let's talk about two issues here, reliability and validity. So if you're familiar with these two terms, since you've taken that statistics course, congratulations. Reliability is the ability for a test to get consistent results. So if you take an intelligence test multiple times, that test is reliable if your scores are very similar. That means that it is measuring something that doesn't vary a whole lot. Well, intelligence tests tend to be very stable. We assume that this cognitive ability that we are calling intelligence is also relatively stable, so that's a good thing. We think of intelligence as being relatively stable, and IQ scores reflect that fact. So we can say that intelligence tests are reliable. But we want to know if they're valid. And validity refers to, is a test actually measuring what it is intending to? Do intelligence tests actually measure intelligence? That's the question of validity. And that's where things get a lot more messy. Most people who develop intelligence tests would say, yes, of course they're measuring intelligence. That's what they were designed to do. We put a lot of work into this, and we think it did a pretty good job. IQs are related to grades in school, and a lot of people would argue that grades in school are, to some extent, a good measure of intelligence. Not a perfect measure, but it is an indication of someone's overall intelligence, which again, I can't stress this enough, was the original purpose of IQ tests. But there's obviously more to the story here. Yes, they can tell us how well a child might do in school, and that is great. But let's talk about some factors that actually influence intelligence, that might have an impact on that IQ score if someone takes an intelligence test. And I want to briefly introduce the biopsychosocial model. It is a wonderfully named model. You can use it for just about every part of cognition. Biopsychosocial model looks at factors from three different areas and how they influence something. So bio refers to biological factors, psycho refers to psychological factors, social refers to social factors, external factors, how that influences someone's intelligence. So let's start by talking about biological factors and how they influence intelligence. So yes, there are biological variables that will influence how intelligent someone is. We tend to see a pretty strong correlation, not a perfect correlation, but a pretty strong correlation between the intelligence of two parents and the intelligence of their child. So there seems to be, at least in part, a genetic component to intelligence. That is not to say that intelligence is completely determined by genetics. No one is making that claim, but it seems to play, at the very least, an important role. Sex is also an important biological factor that influences intelligence. Now, I want to say, first of all, that there is enormous similarity. There is more similarity between men and women, males and females, on IQ tests than there is differences. But some of the differences start to appear when we look at the extreme highs and the extreme lows of intelligence. And what we find is that males tend to be overrepresented at those extremes. So there's more males at the extreme low end of our normal distribution, and there's more males at the extreme high end of the distribution. So it seems that there's something about the male biology that makes these extremes more common. These differences, or there are certain differences that develop from a very early age between males and females. Girls tend to have higher verbal scores. They have better processing speed scores, so they're thinking faster on these intelligence tests than boys. Boys tend to do better on visual spatial processing and better on math. Now, I really want to hammer this point home. That is not necessarily meaning that those differences are solely attributable to biological factors. The difference that I'm talking about here could also be due to social factors. You might have many different boys who are simply told, yeah, you're a boy, you're good at math. And you might have a lot of girls who are simply told from a young age, you're a girl, you're bad at math. That is going to have a huge impact on how smart a boy or a girl thinks they are, how much effort they're going to put into math homework or math class. So just because we see this difference between boys and girls at a young age doesn't necessarily mean that it is caused by biology. It certainly plays an impact, it plays a role, but it is not the only factor. All right, let's talk about some of the other factors in this model. So obviously the social environment, external factors of a person is going to have a huge influence on their intelligence. The immediate environment would be the family environment, the school environment. So this isn't too surprising. If a child comes from a loving, caring household where they have access to stimulating mental environments, if they have access to parents who care about their education, who care about their mental health, then that child will thrive more than a child who doesn't have those. School environment as well. If a child goes to a school that is well funded, that has teachers who are good at their job, they will thrive better than a child who doesn't have access to those things. That's pretty much common sense there. Turns out these environmental influences, like your family and the school you attend, have a pretty profound effect on intelligence. Attending school makes children smarter. There is a gap in intelligence that exists between children from a high socioeconomic class and children from a low socioeconomic class. But that gap gets considerably smaller during the first year of school. So before school starts, we see the high socioeconomic class kids kind of scoring higher on these intelligence tests, and the low socioeconomic class kids scoring lower. But once they both start school, the low SES kids catch up pretty quickly to the high SES kids. So school, in a way, is like the great equalizer. What about during summer break? Well, here again, we start to see some differences between social classes. People on the lower end of the SES spectrum, they tend to see a drop in IQ scores. So over summer break, you might not be exposed to all of the learning environments that you have access to during school. High SES kids, their IQ kind of stays the same. They don't see that drop. This would imply that the high SES kids have access to, what do we call them, educational opportunities that the low SES kids don't. Yeah, no one is making the case that the difference between rich and poor kids is based on genetics. These people who do this kind of research, they're making the case that it's environmental factors that cause these differences. I'm going to skip this slide now. It's kind of just reiterating points that I made on the previous slide. It's really not that surprising that more exposure to poverty decreases IQ. That's not exactly groundbreaking work. All right, now I do want to talk about the Flynn effect. The Flynn effect is named after James Flynn, and he noticed that IQ scores have been increasing over the past century. That's not to say that the normal distribution is changing, it's just that our IQ tests have got to get harder and harder to keep that average based at 100. So if our IQs are increasing, if IQ tests have to get harder and harder to keep that average right at 100, does that mean we're getting smarter as a species? Well, go ahead and watch this short video that I have linked on the Canvas website, and then we will talk about it right now. The answer is no. If you watch the video with Dr. James Flynn, he goes on to say that we're simply getting better at the skills that IQ tests measure. So it's kind of disappointing. Isn't it a great thing to think that we're getting smarter as a species? No, actually, we're just getting better at taking these specific tests. So let's talk about some of the problems with IQ tests really briefly. Bias is a big one. In the past, there was this push to make a culture general IQ test. So a single IQ test that could be applicable for every culture on the planet. That failed miserably. So now instead, what we try to do is create culture specific IQ tests. And I used to have access to these culture specific IQ tests. I had a wonderful little slide that showed a comparison between a typical American IQ test for school age children, and it asked, pretty common questions that you might guess. There was like simple math problems, there were some analogies that you had to finish, some fill in the blanks, that kind of stuff. And then it contrasted with a culture specific IQ test for Aboriginals in Australia. And it asks some questions that they just seemed so bizarre to someone who is not from that culture. They asked questions along the lines of, if a wallaby is to a cigarette, a tree is to a what? Like, you have absolutely no idea. And they also ask questions along the lines of, how many lunar cycles are there in a year? Now, you might know this answer, and the answer is 13. But in this particular culture that they were giving the IQ test, this particular culture did not have a number for 13. They had a number for 1, they had a number for 2, they had a number for 3, but then anything beyond 3, they simply referred to as many. So even though the answer for the number of lunar cycles in the year should be 13, the correct answer is many. So this is a great example of how we need to create culture-specific IQ tests. We can't create one culture general IQ test for the entire world. You might seem very stupid in one culture, but if you're in the correct culture that you were raised in, then you would seem like a normal, intelligent person. Another huge problem with IQ tests, and I really can't stress this one enough either, the usefulness of an IQ score decreases with age. They were meant to determine which children would benefit from special education services. They were not meant to determine who is smarter between two different 27-year-olds or something like that. So think about this. As you get older, your mental age versus your chronological age is going to mean less and less. So let's say a 38-year-old takes an IQ test and they have a score above 100. So their mental age is beyond their chronological age. Okay, so the 38-year-old that took that test is as smart as a 42-year-old? See, that's not super useful. That doesn't really tell us a whole lot. That doesn't really make a lot of sense. So an IQ score is really useful for children. It's really useful for school admissions. It's really useful for predicting proficiency in school, but that's kind of where its limits come after that. All right, my last slide here, I want to briefly talk about Lewis Terman and his termite study. So back in Lewis Terman's day, which was the early 20th century, there was this idea that children who were very bright when they are young will fizzle out in later adulthood. They will be these social recluses. They will be inept. It's the myth was this early to ripe, early to rot. So if they are very bright children, then they will be sort of failures as adults. That was the myth at the time. Lewis Terman, being a good scientist, decided, hey, I'm going to test this idea, see if there's any truth to it, but I'm going to use scientific principles. So Lewis Terman took 1,500 children, gave them IQ tests, and they all scored very, very high. So he took these 1,500 children that had high IQs. They had an IQ above 135. Remember, 130 was our cutoff for normality. So anything above 130 is considered abnormal on the high end of the scale. And what he found is that he followed them throughout their lives. He, kept in contact through mail. He asked them questions on surveys and things like that. He asked them things about their professional lives, their personal lives, just, what's going on. And what he found is that they were actually very successful in later life. And he argued more successful than the average person. They were successful socially, they were successful professionally, they had many friends, they had successful marriages, they had successful careers. Many of these termites in this study went on to become Nobel laureates. They went on to become successful academics. They had twice the academic output as the general population. So it kind of put to rest this idea of early to ripe, early to rot. And that's a good reason why you've probably never even heard of that myth today. the myth that children who are bright will be failures as